Okay, this video we're going to look at the activity for word problems in 2.3 to 2.6 for Math 99. It used to be 140, but we just changed the numbers. What are the steps to solve word problems? Listen here. So hopefully you got that part. This is the directions that you have on the top of every test and quiz, homework kind of thing for word problems. So declare unknowns. Sometimes you just have one, sometimes more than one. You can label with a variable or an expression. You can make a systems of equations if you choose to or need to. For part B, write an equation. Drawing a diagram really can help you, listing out some formulas, those kind of things. A formula, just to differentiate, is what we use for just like distance equals rate times time. That's a formula. When we start plugging in values for that, the given values, then we'll call that an equation. Sometimes you just have to kind of translate and you don't have a standard formula, so you have to make your own equation. Part C, solve, showing work. So you're going to put all possible steps if there's more than one. And then verify results. So even if you're putting things into your calculator or using like Desmos or something, you're going to jot down what you're writing there, what you're typing in, you're going to write down on the paper for me to see. And so you can also reference back and kind of notice your steps. Part D is interpret your answer in a sentence. You're going to look back and see, does that make sense? You're going to put the units on it and some meaning and context surrounding that. Okay, so I've written some things out here for problem 1. So problem 1, we have after riding a steady pace for 40 miles. Okay, so that's my distance on a bike. Bicycle had a flat tire and walked 5 miles to the repair shop. Okay, so distance walking is 5 miles. Cycling rate was 4 times faster than the walking rate. If the time spent cycling and walking was 5 hours, so my total time is 5 hours, what rate was the cyclist riding? So I have a couple of things going on here and I need to declare some variables. So I have my rate walking is what I know least about. That's kind of the most streamlined thing. So I'm going to call that R for rate walking. 4R would be my rate riding. I have some more information about that. We also can set this up. Time riding plus time walking would equal the total time. And we know that total time is actually 5 hours, right? We can set up a little equation here. We know distance equals rate times time. And we can manipulate that to put everything in terms of time because that's how our phrases are set up. So time equals distance over rate. So time riding would be the distance riding, which is 40, over the rate riding, which was 4x, plus time walking, which was 5. Miles is the distance over x is my rate. So remember, distance over time. It just so happens that the number of hours is also 5. So just kind of keep track in your head what the units are. You could write them down. Okay, so now we have a rational equation and we can use the process of clearing the denominator if we needed to. However, if I actually just look at this and I reduce here and I have 40 over 4, that would be 1 there and 10. So I end up with 10 over x and I get myself a common denominator that way. So it's just pretty easy to solve. So I have 15 over x when I combine like terms equals 5. And now I can multiply or cross multiply, right? So I would have 5x equals 15. Move that up. And so therefore x equals 3, or actually I think I was calling it r, so I'm just going to go back up here and change these to x instead. That's my unknown. I think that's what I did on the hints too. So we'll be consistent with that. So if we have x equals 3, are we done? What is x represented by? That's the rate walking. So this is walking. It's like miles per hour, right? So we have to go back up to here and fill this in. So my rate for riding is not quite done yet. I have to do 4x, and that would be 4 times 3, so it equals 12 miles per hour. And then I want to write in a sentence, the cyclist was riding at a rate of 12 miles per hour. Okay, so we have all our parts here. We have A is the declaring, B is setting up my phrases in my equation, which we write here. My work steps and solving are done out, and then my answer in a sentence with units. So for number 2, this is a work problem, and they have a pattern as well. A demolition company wants to build a brick wall to hide wrecked cars from public view. Working together, we have an experienced bricklayer and an apprentice. Together, they can build the wall in 12 hours. Working alone, it would take the apprentice 10 hours longer than the master bricklayer to do the job. How long would it take the master to build working alone? So again, we know less information about the master, so we're going to call that x. So let x equal time. I think we want it in hours, so we could even say number of hours for master to complete. And then we could let x plus 10, that's the relationship we need to have there to make it kind of a systems there. You could do it as one is x, one is y, and do y equals x plus 10 as a system of equations if you want to do it that method. That would be the number of hours for apprentice to complete. And now we're going to set up the equation. So the equation here, we're going to take the total hours, this is pretty standard, over time for one. Okay, total hours if both were working. Okay, and then plus your total hours for both over time for one, or I'll say the other the other one equals one whole job. Okay, so in essence what I'm saying is we'll set up the master here. The master, if he were to do the job, we would have the time for his job is unknown, right? So we would say the total hours if they were both working together, right? And we're going to take his portion would be dividing by x. So we want to write 12 over x. Okay, so that's his part of the job for the master. And then the other apprentice is 12 divided by x plus 10 to get his portion of the job, represented as an expression, equals one whole job. Now we're going to clear the denominator. On this one, I do want to do that. It's a little easier than trying to get a common denominator and all that. My LCD that I can clear with is x times x plus 10. Now be careful here. Make sure you use parentheses. I've already sketched them in here. And that way you don't miss out on distributing. Don't forget to do this side on the right hand side there. So now I can look at reducing. So I'm going to have the x's reduce out there and leave me with 12 times x plus 10. And now I have the x plus 10s on this term. The second term is going to be reduced, and that'll leave me with just 12x. And then equals x times x plus 10. I'm going to go ahead and calculate that out. X squared plus 10x. Now I need to simplify all this because I need to have this as it's a quadratic. So I need to set it all equal to 0, and it is going to be factorable. So on this one, I'm going to actually just write this. I'm running out of room. I'm going to write this as distributed 12x plus 120. And then once I set it equal to 0, I'll have 0 equals x squared minus 14x minus 120. And then I can factor that to be x minus 20x plus 6. All right, so I'm going to have x equals 20 or x equals negative 6, but you can tell here the negative 6 is going to be extraneous because I wouldn't have a negative time to complete the job. So my answer is going to be let's squeeze that in here. It will take the master 20 hours if working alone. And that's to complete the entire job if you were all by himself. And that kind of makes sense there if you think about it, that 12 hours, putting those times together, that it should take him longer than that to be working by himself. All right, so that's it for this video. Thanks for watching. Let me know if you have any other questions. I did post some additional resources. These are a little tricky to think about, but just if you know this formula here, this is critical. That's the pattern you want, and there might be variations on the relationships amongst them, and like it could be 4 times faster, or it could be 3 hours longer than twice as fast, or some kind of relationship that this might vary, but this is pretty standard here for the setup of work problems. Okay, have a great day.